All right, here we go. We got the study guide for chemical reactions, conservation of matter, and natural resources. You can go ahead and go through this here. Just sliding down like this. How can you tell a chemical change or reaction has happened? Use your five senses: see, smell, taste, hear, feel. That's a simple answer on that. Reminder, study guide is typically more complicated than the test is. The test is not just all these short answer things. It's a lot of multiple choice, a few explanation things. Definitely should be easier than what you're looking at here. Who or what can cause a chemical reaction? Both Mother Earth and people. Name as many signs or clues that a chemical reaction is taking place as you can think of. We named at least 7 in class. Here's a handful, more than 7. Fizzing, color change, smell change, explosion, fire, smoke, volume or size change, volume, sound change. That's not all inclusive. There are other things. 5 or more examples of chemical reaction, not signs that one takes place, but actual chemical reactions. Rust, baking cookies, frying an egg, fireworks, Alka-Seltzer, vinegar and baking soda, and there are others. Iron is exposed to oxygen and moisture, resulting in rust. What is the chemical formula for rust? Fe2O3. It's going to be directly on the test, so I would make sure you know that. What's a reactant? Something that combines with another reactant in a chemical reaction. Examples are vinegar and baking soda. What is a product? It's the result of a chemical reaction. These are notes that are actually on the board on our group notes page, our group notes board, I should say. Conservation of matter. Matter is neither created nor destroyed, only transformed. The mass of 2 reactants is equal to the mass of the products. So that's going to be a key thing you want to know. What are natural resources? Give 2 examples. Things in nature, like wood, oil, wind, water, or vegetables. Our definition on the board is actually made in nature. So, pretty simple. Synthetic resources, again, taking the board definition, man-made through chemical reactions. Man-made through chemical reactions like plastic, medications, or gasoline. How are natural and synthetic resources related? Synthetic resources are made from natural resources. For example, gasoline is made from oil. What's biodegradable and how is it helpful to an ecosystem? Things which are biodegradable break down over time, so they're less likely to harm an ecosystem. Compost is biodegradable. Styrofoam is not. I'm going to flip to the other side. Okay, draw a picture of a chemical reaction which demonstrates conservation of matter. In the model below, be sure to note how many hydrogen and oxygen there are on each side of the chemical equation. So you started with something that looks like this. And if you read the key down here properly, you should see that there are 8 hydrogen, 2, 4, 6, 8, and 4 oxygen, 1, 2, 3, 4. And then you're trying to turn it into water. So water is H2O, HHHH2, OOOO, and then 2 H's on each of those. It doesn't matter which way they face, but you do want to try to make sure that they are looking relatively the same when you redraw it. And so we still have 8 and 4. Fitting corrosion in marine applications. I can tell you right now, this graph that I put on here is way more difficult to understand than the one that's on the test. The one that's on the test you've seen before. It's on the snap sheet for this unit. Pretty straightforward. It's the one that looks like this. We even used it in class. Super easy. You should not have any issues with it. But let's look at this more complicated one for starters. So based on the graph above, which group resulted in the greatest chemical change and why? You can see I even struggled reading this one. It should be D. I had C at first, but it's actually D because D goes all the way from this 0.01 chloride ion concentrate down to 10 or even higher than that. So that is why it's going to be changing the most, and that is what the answer written there says. Based on the graph above, which group resulted in the slowest rate of chemical change, and how can you tell? That one's going to be A because it moves far less than the others. It's just this little bitty, very little chemical change right there. And then which group worked at the lowest temperatures? That one should be pretty easy because we're just looking at the temperature scale here going from 100 degrees down to 0 degrees Celsius. So that's going to be D. It works at 15 degrees Celsius. That is the study guide for your chemical reactions. Natural Resources and Conservation of Matter quiz. Quiz is on Wednesday, December 4th. So you had any questions, definitely make sure to review this video or fill out your worksheet, your review guide, and review that. Thanks so much.